Is my screen visible?
Yes, ma'am. Screen is visible.
Okay. So starting with the theorems and everything, the results and everything from week 7. So if there are any doubts from the theory part of week 7, then we'll start with the activity questions.
Can you explain about the subsequence law?
Subsequence. Okay. So if you have a sequence, say, if you have a sequence, say AN, so you have A1, A2, and this is what it is, right? A3, and so on, so on. So it keeps going on, never stops. So this is your sequence, and a subsequence of this sequence simply just means that you keep taking some terms from starting from here. So you can take A1, and then it's not necessary to take it. So it just means that it is, you can take this term and then this term and then some other term, but you just have to make sure that we're not defining it formally in the formal terms here. I'm just letting you know how it is constructed, how you can construct any sequence from any subsequence from a sequence. You can just choose any terms, but just make sure that you put them in the right order. So A3 should come after A1 only. So you can't, a subsequence can't be A4 and then you choose A3 and then you choose A2, then A9. You can't do this. This is not, if this keeps going on, this is not a subsequence of this, but if this is at A1, A3, then A7, A9, A20, anything that comes after A9, you can take that as the next step. This is a subsequence and this isn't. This is how a subsequence works. Is that fine?
So I have doubt in that. For example, if we take a function 1 by n square, is it a subsequence of a 1 by n?
Yes, it is, because it's 1 by n is this, right? 1, and then you have 1 by 2, you have 1 by 3, and so on, so on. So if you look at this, you'll have 1 by 4 after this. And after some time, you'll have 1 by 16 as well. 1 by 9 is somewhat here. Then you have 1 by 25 as well. So you're just picking these. That's what I said right now. No, this is then the take next term to be this, next term to be this. So if you keep choosing these terms, this is 1 by n square only. So 1 by n square is a subsequence of 1 by n, right?
Okay, then I was understood.
Okay. So any other doubts from the concepts from week 7?
Ma'am, does
Ma'am,
subsequence
I have
need to
some
have the same
questions.
order as the main sequence?
Can you repeat?
Does subsequence need to have the same order as the main sequence?
Yes. If you, like, as I said, if
Ma'am,
you take,
excuse
say,
me.
A4 here, yes,
Hello.
Ma'am
yes,
is
yes.
meeting. Hello.
What is it?
Ma'am is meeting the password to remember.
What?
Is meeting the password remember?
I think you should speak to the support team regarding this.
Okay, ma'am. Okay, ma'am.
So about the subsequence, one thing you need to keep in mind is if you start with A4, so you can start with anything, and then you need to keep in mind that the next term would be after A4. So A4, you can have A5 here, A6 here, A7 here as second term, but you cannot have A3 here.
Okay, ma'am.
Other doubts? We're just discussing the concepts of subsequences, sequences, and all.
Ma'am, I have doubt in some questions, in activity questions.
Yes, we'll
Excuse me, ma'am.
discuss it after the concepts.
Ma'am,
I just want to make sure that there's no doubt in the concepts. Yes.
Okay, ma'am.
ma'am, can you keep that advert ID of my name? It's
Is it regarding the permission to join the meeting and all? I think you should contact the
No,
What is
ma'am.
it
I
about?
have tried to join the meeting from my browser and from the app, and the other ID is joined via the browser link. So I have not able to leave that meeting from my side. Uh, From my name, there are two IDs in the class.
Okay, so in this class, you joined with two IDs.
Yes, ma'am.
So,
Can you
it,
keep that ID?
what?
Ma'am,
Yes,
ma'am, the domain of subsequence is natural numbers. Is there is any constraint for its range?
constraint for what?
Ma'am, means such that we say that domain is natural number. Is
Yes.
range is also natural number, or it can be real number?
No. A sequence is defined as a function from natural numbers to, you can have a sequence. You're just dealing with real numbers right now, but we can have sequence of complex numbers too. So there's no restriction on what your range would be. You can have anything as
Okay, ma'am.
range. Okay.
But the range should be from natural number.
Yeah, the domain should be natural for a sequence. The domain should be natural numbers, this set. And the range can be anything, but since we're only dealing with real numbers, so we'll keep it real here. It doesn't have to be all that, obviously, the range, I should write codomain here. This is it. Anything else from the concepts?
No, ma'am.
Okay, so we'll just move to the exercises then, the activity questions. Starting with 7.1. Any doubts from there?
7.1 10th question.
I think 10th question was discussed in the last class. Can you just check that video? It's discussed there in detail in the end. Um, okay, we'll take that after other questions from 7.1. So if there are there any other doubts from 7.1?
No, ma'am.
Okay, let's
Ma'am, we
just
can
take
ask doubts from only concept, not from activity questions.
we're, we're doing activity questions now. The concepts are done, right? No one has a doubt in it anymore. So
Okay, ma'am.
okay. Question number 10, someone asked. So though I've already done it in the last class, but we can just quickly go through it. The first statement is about mx plus c. This is the function being a 1, 1 function. So this, the graph of it looks like this, or it can be something, it depends on m and c though. So it's something like this. It doesn't have to be this, but it's a straight line. And it is a 1, 1 function, right? So if you draw any horizontal line, it will cross this line only once. So this is a 1, 1 function. And then the second option is x squared plus bx plus c is an onto function. We just checked in that it's basically what you do here is you just take any real number and then you try to see if the solution of this turns out to be, if there is a real solution to this equation for every real number r, then it's an onto function. Otherwise, it's not an onto function. So you can check it. There are real numbers r such that this equation does not have a real solution. That is why it's not an onto function. The second option is incorrect. And then the third one we did was e to the power minus x being unbounded. So e to the power minus x's graph looks like this. So it is an unbounded function on R. This is correct. And then at the end, the last option is 1 plus 1, 1 by 1 plus ex. and it's from real numbers to 0, 1. So if you try to find the inverse of it, you will see that it will be y we will have a so the inverse will be this natural log of 1 minus x by x. This is the inverse of this function, and if you check the domain of this, it's 0, 1, right? So the inverse of, because it's from R to 0, 1, that's why its inverse exists and it is this. So the last option is correct too. Is it clear? Whoever
Yes,
had
ma'am.
a doubt in this. Okay. So next we are doing
Can you do the
7.7.
11th one? 11th one, 7.1.
Okay. You have x plus 1 by x. Then there are some options. F is an injective function if the domain of f is R minus 0. So this is the domain of this. It says that it's not an injective function. If you see, if you put a 2 here, you'll get 2 plus half. And if you put a half here, you'll get half plus 2. So f2 and f half. And how can we guess it? Because it's x plus 1 by x. So it's easy to just quickly see and analyze that if you'll put a 2 here and if you'll put a half here, you'll get the same value. These two are same. So you would have to remove rational numbers from the domain. At least they need to be removed from here. Right, so the first option is incorrect. First one says that it's injective for domain equal R minus 0. This is incorrect. Second is same injective when your domain is natural number. So if you restrict your domain to natural numbers, now if you take a 2 here, you can't take half here, right? So if you take a 2, to match the value, you'll have to take a half, but half is not in natural number, so this should be correct. Natural numbers work. And then third, we have injective if the domain of f is q minus 0. Even if you take the domain to be this, we have the problem with rational numbers mainly, because if you substitute a rational number here, not rational numbers exactly, but if you substitute a rational number here, there's another rational number such that f2 and f half, and it happens for literally every x. So if you want that x plus 1 by x is not equal to some other y plus 1 by y, you need to just make sure that your x is, I mean, obviously natural numbers are also rational numbers. So what we want is we want 1 by x to be not in the domain. That's what we want. Because if 1
Yeah,
by
got
x
it.
is in the, you
Got
understood,
it.
right?
Yeah, let's go for the fourth option.
Okay. So the fourth one is f is surjective function if the domain of f is n and codomain is q. So it will take n and q here. So
Fourth option
it
is
is surjective, right?
injective.
Because if
Fourth
it is
option is checking for integers. Injective for integers. Fourth option.
okay, injective for integers. It's the same for integers too. If you take z minus 0 here, if this is the domain, then we have a problem. The problem is with, we have to identify the problem. The problem is with the inverse of x. Inverse as in multiplicative inverse. So if you have x in the domain, you should not have 1 by x. So if you look at integers, if you have integers are these, right? Minus 1, minus 2, and so on, and 0, 1, 2. So you'd want, if 2 is in the domain, 1 by 2 should not be in the domain, right? And you have excluded all of it from here, no? There's no 1 by 2 in the domain. 1 by 3 is not there. So you've made sure that these
So 4 is
inverses,
correct.
yep, this is correct.
Okay.
And then for the fifth one, the functions from, if it is from n to q, then it is a surjective function, because if you'll put a natural number here, say any natural number, and then you'll do 1 by n here. So it's definitely natural number plus multiplicative inverse of a natural number is obviously a rational number. And okay, so it's here. And can we have, okay, let's just have a p by q here. And then just see if we have an x such that x plus 1 by x is equals to p by q. So we'll have x squared plus 1 by x equals p by q. Right? Let's just try to see if we get a real solution for this. Q is equals to px. And we'd want a real solution for every pq belonging to integers, you can say, or for more clarity, you can say p belonging to integers and q belonging to natural numbers. This covers all rational numbers, right? So you can take this, then you have a quadratic equation and just try to check it. So we can intuitively tell that this is not going to have a real solution every time for every p and q. You can still try to check it for more clarity. You would want p square minus 4q square, right? You would want this thing to be greater than 0, or at least equal to 0. You would want p square to be greater than equals to 4q square, or you can just say that you want p minus 2q, p plus 2q. So it's p greater than 2q and p greater than equals to minus 2q. That's not the case with you can't, for every p and q belonging to, let's just forget about integers. If you will take p and q from natural numbers too, p, q are arbitrary, right? So you can take any natural number here. So if that happens, this is not always going to hold. Either you want this to be true or you want this to be true. P, so you'd want P to be greater than 2Q and greater than minus 2Q, or P to be less than 2Q and less than minus 2Q. Either this or this. This isn't, can we just find a P and Q for which none of these hold?
Yeah, it works only for p and q equal to 0, no?
No, it works for a lot of P and Qs, but it doesn't work for a lot too. So if you take, for example, P to be 1 and Q to be 1, 2, so you have, so is it working out for everything? We just don't even have to do all this. We can just figure out from here only. You can have, so P and Q can be taken from, if we take P and Q from natural numbers, there are definitely natural numbers such that your P square is greater than 4Q square, right?
Yeah, there are.
So, and there are a lot where your P square is not, so you will get every type of natural numbers. This is also a possibility. And if this is true, then your discriminant is going to be positive. So this will lead to a real solution of this equation, right? But there are P and Qs such that your P square is actually less than 4Q square, right?
Yeah.
So for those things, you'd have a negative in the square root. The determinant would be negative and it will lead to a solution that's not real. So all in all, the point is that you cannot, then it shouldn't be surjective.
Okay.
Excuse me, ma'am.
Yes.
Ma'am, you are taking doubts or summarizing week 7?
We're taking doubts for week 7, but if there's something particular that you want me to just quickly recap, we can do that too here.
Ma'am, I have a doubt in quiz 1 question. So may I send it?
Quiz 1, we're taking the doubts for week 7 right now. So let's just get over with those first and then we'll take your doubts from quiz. Is that
Ma'am,
okay?
every Tuesday the doubt sessions are conducted.
No, not every. I don't think so.
What can about the codomain, ma'am? Except rational numbers, can natural numbers be the codomain?
Natural
Or this?
numbers. No. The problem is with the there are natural numbers cannot be. The set of codomains does include the rational numbers. When you have this thing x plus 1 by x, and if your it depends on the domain, but if your domain is natural numbers, then the codomain the range will have rational numbers in it. This is contained in not entirely contained. That's not true, but there's a part of rational numbers that is in the range. What exactly are you asking?
I'm asking about except rational numbers, can all the type of numbers be included? I mean, real
No.
numbers or natural or integers, except
In
rational.
the range,
No, voice is breaking.
where do you want to include those other numbers? In the range? Are you
No,
talking about the range?
I am talking about the codomain.
Okay, range is the main thing. Codomain is not really that important. You just need range, and
Yeah, but in option they
codomain
said
you
about the
can
codomain.
codomain you can take if there is a function from, let's just say, a set S to another set, say S dash, then you can, if the codomain can be anything. If you want the function to be onto, then your range should be equal to codomain. Then your range has a restriction. Your codomain it doesn't have any restrictions.
Oh, okay.
You can take codomain to be anything. Obviously, the range, one important thing is that your range should be contained in the codomain. So it should be a superset of range, that's all. Otherwise, codomain can be anything.
Okay, ma'am.
Unless you want the function to be onto. In that case, your range and codomain need to be same.
Yeah. Okay.
Any other doubts from 7.1?
Question number 10.
Then we just discussed at the start of this session.
Ma'am, is 1 by e raised to power x is unbounded on R?
We've done this in the last class. I'd suggest you to just go through the last lecture, the one that you guys had before this one. We've discussed this question in detail there at the end of the session. Please go through that.
Okay.
Okay. So any other doubts from 7.1? Well, 7.1, otherwise we'll move to 7.2 then. 7.2. Any doubts from there? Do we have any other doubts from 7.2? Any doubts? We've not even done one. From 7.3, let's just move to 7.3 then. Any doubts from 7.3?
7.2 third question, can you take
7.2.
third one? It's written fg of 0 or 1, but fg means fg is
FG
not equal to
means
f of g, right?
it is F. It's
No, according to the theory, like the lecture,
okay. Then it's
fg
either multiplied with it or
f of x, yeah, f of x into g of x, and not f of g.
sometimes we do write the composition thing as FG as well, but here it's multiplication. Just multiply the,
How?
yes, it's multiplication here.
No, if we apply multiplications, I don't think it's that answer is coming.
Okay, let's just try
Zero.
multiplying it then.
If you multiply, you get 3 as the answer. And in the lecture also, fg is understood as f of x into g of x and not f of g of x.
Okay, so let's multiply it and see what
3 into 1, that's
here.
all. X is 0.
How can you get 3 into 1 here? There's no negative sign. Okay, after
No,
substitute
x is 0.
Okay, let's just do it here. And what's the answer?
Answer is 6. It's saying f of g of x answer. It
So
is
do you get
asking
it
for
according
fg
to the
of x.
composition?
Yeah, yeah. When I apply composition, I'm getting 6.
Okay, and there it must be a mistake here.
Okay.
Okay.
Can you handle also question number 4 and 5 almost similar? I got sine 2x is equal to 2 sine x cos x, but I didn't get sine 3x is equal to 3 sine x minus sine cube x. That I didn't understand.
Okay.
Sine 3x is equal to 3 sine x minus 4 sine cube x.
This, right?
Yeah, this and the
So,
cos,
and you're
this and
supposed
the
to use
cos
this
one.
thing. Do you want me to do the fourth one or the fifth one?
Yeah, fourth and fifth, that similar cos functions. If I can derive it from this, I'll derive it on my own. But those are my two doubts in that activity.
So you're not able to derive this, right?
Yeah, this I'm not able to derive.
So you don't have to derive it, by the way, you just have to check it. Okay. Even if you're able to see that these two are equal without actually starting from we'll trace it back and then we'll see how it's done. Okay. So it's sine 2x. You're able to get that it's 2 sine x cos x, right? This much you've understood.
Yes.
And the identity and then cos 2x has been given in the next one. You
Okay. Yeah.
the cos if you apply the cos 2x identity from the next question because you'd have to, otherwise what happens here is if you take sine 3x, you will get sine 2x cos x and cos 2x sin x. And from what we see here, we need a sin x. We need everything in terms of sine and x, right? We don't want to and all of this here. This can be adjusted, it's here, but we need this to be replaced too because we don't see it here, right?
Got
That's
it.
why we need to use cos 2x as well. It's cos square x minus sine square x. It This is derived from the formula that's given in the next question, the fifth one. These two are like directly derived from the formulas that are given in question 4 and question 5. These two you need to apply. When you will apply sine 2x here, you'll get 2 sine x cos x. Then there's already a cos x here. When you apply cos 2x, you get cos square x minus sine square x. There's already a sine x. This is sin x. This is right. This is what you get. And in the question, you've been given something entirely different. So we want to check if this thing is equal to 3 sin x minus 4 sin cube x. Right? So one thing that you can do here is you can just cos square x is 1 minus sin square x, right? Either you can do this. Directly get 3 sin x minus 3 sin square x, and we already have a sin cube x here. So you're getting exactly what's given in the options.
Yeah, got it.
And
So
you do
do
this
we have
one the
to
same.
learn all these identities? Like there are a
No,
couple of
see, if you
list
no
of
no no,
identities.
it's the basics. If you do it, it'll be better. It's like the very basic stuff. This one, you don't have to do all of them, obviously. And if even if you don't want to do it this way, you can just then you'll have to somehow try to figure out if these two are equal or not, right? So we can do it in another way. Do you want me to like give another way for this
Yeah, yeah.
that you
If you
can try?
please.
It will be just trying to figure out if these two are equal or not. That's our aim, right?
Correct.
So we'll just put them equal, and if something like some inconsistency appears, like this thing, if this is something we
Okay,
get
okay,
something like
got
this
it,
at
got
the
it.
end, then it's false, right?
So either you can go from known to unknown or unknown to known.
Yeah, just try to see if, and if they turn out to be equal, we'll
Got
just
it,
see
got
this.
it.
You
Yeah.
want me to do it further, or is it okay?
No, no, no. It's okay. I'll try out stuff.
Okay. Any other doubts from 7.2? Okay, let's move to 7.3 then. Any doubts from 7.3?
Ma'am, question number 1.
Question 1. You've been given a function x square plus 1, which is from R to R, right? Which of the following options represent the graph of the function? So how do you, in form of a set, how do you represent a function, right? That's what we want to know. The graph of a function is this. Let's just say this is a function. The graph of it looks like it's x square plus 1. So we'll have to complete the square here. But let's just say the graph looks like I'm not saying that it looks like this. Let's just say it does. We're assuming it, but we're not saying that this is the graph of this. So if it looks like this, then the graph is actually the collection of points that are on this line, right? So it's basically the collection of the points that satisfy this thing. It's the collection of this such that your y is equal to fx, right? This is what a graph is.
Yes.
So you'll have what is y here. Instead of writing x, y, where your y is equal to x square plus 1, you can just directly replace y with x square plus 1. You can do this thing. And then we know that the domain is R. So we can just say that you'll have to mention where your x belongs. You have to mention it belongs to the set of real numbers. So this should be it. Is it okay?
Yes, ma'am. Ma'am, I have another doubt regarding inverse.
Regarding what?
Inverse of a function.
Okay.
Ma'am, like finding inverse, we generally interchange the x and y sub and calculate the inverse by
Yes.
expressing. But if it is not easy to do like that, then how can we do it?
Okay, what we generally do is we we know how we generally do it. We just calculate x in terms of y, and then we replace x with y and y with x. So for that, I need a function where it's difficult to. Have you been given questions and functions where the inverse cannot be calculated using this?
I don't have in any particular right now, but yeah, I have seen many.
There are many where it's not possible for you to write x in terms. Yeah, x in terms of y. It's not, you can't explicitly write it in terms of y. But do you need to do it here? Is it in the course till now?
Till now, I have not seen, but I was doing some questions
Okay,
online. There I saw that.
let's just see a function that can.
Okay, ma'am. Let me search for it.
In the same activity, 7.3, I have doubts with 2, 3, 4, 5, and 6. 2, 3, 4, and 6. All the graph questions.
It's whoever's doubt it was. It's if you can't usually calculate, you can't find x in terms of y, then you won't be given questions like that. So, and there are like, if you'd have to, you won't be given questions like that, by the way. But there are other methods in numerical methods and all, but it's not here. There are, you probably study them in bachelor's if you're doing bachelor's in maths or something. So that's not here.
No, ma'am,
You
I
don't
have
have to.
I've
Okay.
seen that in class 12th.
Okay, so just tell me the question then.
Ma'am, right now I'm not getting it. Can we do it in next class?
Yeah, sure. Okay. So any other doubts from this exercise? We're doing 7.3.
Yeah, could you help me with question number 2 to 6?
2 to 6. Okay.
The graph questions. Yes.
Question 2, and there's a graph. A rough graph that I'm drawing there. This is touching this thing at only one point. And then this is 1 L2 and L3. And this curve is C. So asking you which of the following statements is correct. L1 is the tangent line at some point to the curve C. So L1 is, we've discussed the tangents in last class in detail, what a tangent is. So it to give you a rough thing, it's like this. It gives the direction of the curve at the given point. So if you want to find the tangent at a given point, say this point, then it will be this. At this point, it will be this. And it definitely does not cut the curve at 2 points. This is not a tangent to this graph. This is a tangent to this graph, and this is not even touching the graph anywhere, so this is not a tangent. Is this okay?
Yeah, thank you. So when it comes for the real direction, so I should take the consideration to the vertex point, or where should I think for the tangent part?
As in, are you talking about the definition of tangents?
Yeah, because you mentioned the tangent is something to do with the
Yes.
direction.
If,
So
yep, if you have a graph like this, it basically would, tangent actually means to a graph. Let me just say that this is a point and you want to find the tangent at this point. So it's basically what gives you the direction of, it gives you the direction of flow at this point. So basically it just touches and crosses it, like this one. You have this is, there are, you can't just say that it just touches it and passes. So it's not a line where, that's not how you define it. It's defined in this manner that it gives the direction of the flow of your curves. So if you, for example, if you look at this point, the tangent would be this,
okay,
something like this. This is the tangent. If you look at this curve here, at this point, the tangent will be this.
okay,
And it's in the positive direction of x-axis, in this direction.
okay.
Is that all right? I think
Thank
you
you.
should be able
Yeah,
to do
thank you.
the question, the third question then, and
Yeah, okay, I'll check with it. And question number 4 is something, is the same, something similar to that. Okay. Fine, I'll try with question number. And I'm sorry, I couldn't get that the question 5, the level 2 part.
I can't
Answer
hear
question
you.
7. Question number 7 and 8.
Question 7 and 8.
Yeah, the graph.
So again, we have a graph here. It's like this. P, Q, R, S. The point T here. So if you look at this, these two, at P, at point P, there's no tangent. At Q, there's no tangent. At point P, there is the infinite number of the number of tangents cannot be infinite. We've already discussed this because there could only be one direction of flow. So the third point is obviously incorrect. And then P and Q do not have tangents because it's, you have a sharp point. It's, if you'll be at this point, it's a sudden turn. It's
Okay.
not flowing like a smooth curve.
Okay.
So while you're here, you'll have a tangent here, 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 but you suddenly turn from here. So it's, give me a second. Yes, is it fine? Do you
Yeah.
understand why we don't have a tangent here? Because we have
Okay.
a sharp end here. If you go smoothly, you'll have a tangent everywhere. If you suddenly turn like this, it won't have a tangent here.
So it will be none of the above in this case.
Yeah.
Okay. So in case if the S has a smoother curve, then that will become the tangent.
What?
If S at point S, if it's a soft curve, then that will become the tangent here.
Yes, if you have a curve like this, then the tangent is, see,
Okay.
tangent is basically if you have something like this and you, it gives you the direction. Let's just say we have to draw this graph further. It will give you the
Okay.
direction of where the graph will go.
Okay.
So if this is the tangent at this point, let's say your graph is going to be moving in this direction of the tangent's direction, right? For example, at
Yeah.
this point you have the tangent this. So it is moving from here, you have it moving in this direction. Here you have it moving in this direction. These are tangents.
We cannot have
Okay.
tangents at the endpoints, right? Like how you said.
At the end points,
No. In the latest graph you drew at the bottom,
this
you
one,
explained that at the end, you said at the end, the other side.
Yeah, talking about the tail. No, tail end. Tail end. He
Tail,
was talking about the tail.
tail.
This one?
Yeah.
There we cannot have tangents, right?
Yeah.
Because we can draw multiple tangents at one point, so it's not possible. We can find it just before that end point. Yeah, got it.
Okay. Any other doubts related to tangents and all?
Ma'am, question number 5.
Question 5 of 7.3.
Yes.
Excuse me, ma'am. I have a doubt, not regarding this, means regarding this only. Can a curve be have a sharp edges?
Yeah, everything that curve is can have sharp edges. Why can't it? Why wouldn't it have sharp? It can have anything. Curve is basically a graph. That's all. That's how you define a curve. It could be this. It could be this.
Ma'am, can we
Have
consider
sharp edges.
modulus as a curve? Modulus graph as a curve?
Yes, it's a curve. You don't have to have a curvy thing here to call it a curve.
But I just get to know that what is the definition of a curve means it should have a smooth and edges. It should not have any sharp points.
No, that's called a differentiable function. It has nothing to do with a curve.
Okay, ma'am. Yes, thank you, ma'am.
Okay. Yes, someone had a doubt in question number 5. We just discussed what a graph is. So this is a graph, right? Graph is when you draw a function here, this collection of these points, when you collect them is the graph. So if you write it in set form, it will be this. We just discussed it. It's y is equals to, this is it. And you have been asked which one of this represents a graph of quadratic functions, right? So this means in first option you have y is equals to x cubed plus 2x plus 1. So quadratic function is where it has its general form as this. So anything that looks like this is a quadratic function. A, B, C belong to real numbers.
Yeah, ma'am. Now I got
Okay.
it.
Any other doubts from this exercise?
Number 6.
Question number 6.
Yes.
F is a function from A to B, where A and B are subsets of R and cardinalities of the set A and B are 4 and 4. The cardinality of A is 4. The cardinality of B is 4 as well. What is the cardinality of this thing, where this thing is graph of F? So graph of F is x, y, we just discussed it, it's here. So if you have, in A you have 4 elements, in B you have 4 elements as well. So when you draw a graph, let's just say this is your domain, this is your codomain. You have 4 elements here, and you have 4 elements here. What matters is you don't have to have all of these elements here. When you will, let's just say I'll call it A1, A2, A3, A4, and I'll call this B1, B2, B3, B4. So when you collect the elements here, you can have A1. So A1 should be here. Something from A2 should be here. Something from A3 should be here. Something from A4 should be here. You should have these things because from your domain, if this is a function, you should have an image for every element in the domain. So A1 should have an image, A2 should have an image too. And all of these should have an image. But B1, B2, B3, all of them don't have to be here. So you can choose what you want here because you don't have, when you've simply been given a function only, there's no restriction on this function. it is not 1, 1, not given to be onto. So there's no restriction on this function. You're just given that this is a function. So all you need is that A1, A2, A3, A4 should be here because A1 needs to be mapped somewhere. Do you get what I'm saying? The one who had this question.
Yes, ma'am. समझ तो गया हूँ मैम, but if there is a set of pair points, then how we conclude the lower bound of the set? Like if there is a single element then we have lower bound the first one element, like 1 to 2 open interval या closed interval.
Okay, 1 to 2 what? Good.
Sorry for the
Exactly. So
disturbance, noises. अगर एक ऐसा एलिमेंट है 1 to 2 तो इसका लोअर बाउंड 1 माना जाएगा, बट ऐसे पेयर ऑफ एलिमेंट्स होंगे तो इसमें मैं लोअर बाउंड कैसे डिसाइड?
you have not been asked the lower bound, right? In sets, if you have a collection of these, this you'll have to define what the lower bound of this means. We don't have a term uh, as such for sets like this. In fact, we don't even define lower bounds of sets unless we have an order there. To define a lower bound of a set, you leave an order there. Order as in real numbers, you have an order. 2 is less than 3. This is the order. So you need an order here. Here you don't have an order. Is it in some question?
यस मैम, उसमें लोअर बाउंड पूछा है, सेट ए का जो कार्डिनैलिटी है उसका लोअर बाउंड पूछा है मैम.
It's an eighth question.
No, they're just. I think you've mentioned the question wrong.
यस मैम, मैंने थोड़ा देखने में गलती कर दी,
Cardinality
बट यस
means
क्वेश्चन
that's
नंबर
all
8.
right. Cardinality of the set it is, right? So the cardinality is, let's just say if this is the set, the cardinality is 4 of this set. So it's not, you don't have to calculate the lower bound of the elements here, just the cardinality here. That's all. So if
Yeah,
this is the set A,
I think he captured he mixed question number 6 and 8.
okay. So
No,
question
I
8
mean for
is,
8, question number 8, just numbering की mistake होगी, but मेरा मतलब question number 8 से.
okay. Let A be the set points where the curve C has no tangents. Find the lower bound for the cardinality. Let's just see. It is, what is this question? Do we have, if this is a sub question, right? Where's the main question? Okay, so this is the main curve. We drew this curve here. This is the main curve. And your question is, let A be the set of points where the curve has no tangent. So it doesn't have a tangent here, doesn't have a tangent here, not here, and these are the only, this is also a point.
Q, not
It
that
doesn't
point.
have a,
Q. PQ or
sorry,
S, not C.
C is also mentioned in the curve. Okay, C is the curve itself.
Q. Between P, you have written Q, no? That also doesn't have tangent.
Yeah,
So 4
none
points.
of them has a, this, and this. None of them has a tangent.
That's a 0. Yeah, it's a, none of them, no tangent is.
Find the lower bound for the cardinality of the set A. So we can clearly see 4 points that do not have tangents, and then
Yeah, that's all. This is a
A
part of
is,
the curve. If they extend on both sides, it might increase, but the lower bound is just 4.
but we've not been given exactly the domain. So if this curve, this would also be a point where there's no tangent, and this ends here, so this would also be one of those points. So if you've just been given, okay, it's the lower bound, then for lower bound you can just say 4. It's not the upper bound, right? So we don't, there are at least 4 points we can clearly, you've been asked lower bound, so the lower bound is 4 here. we don't have to worry about the end points here because they're asking the lower bound. So you at least have 4 points here which do not have a tangent.
ओके मैम,
Four.
अगर अगर यहाँ पर ऐसा कोई सेट हो जो पेयर्स में या ट्रिपलेट्स में या जो भी फर्दर पेयर्स बनते हैं, जो भी पार्ट बनते हैं, अगर ऐसा कोई कलेक्शन ऑफ सेट दिया जाए तो उसमें हमें जो डोमेन डोमेन सेट है उसके जो लोअर बाउंड्स हैं उनको काउंट करना होता है, तब जाकर उस पूरे सेट का लोअर बाउंड बनता है.
They're not going to ask you the lower bound of sets like these. Otherwise, they'll define what they mean by the lower bound. That's what I was trying to tell you. They'll define an order somewhere.
Okay.
Lower bound would be what happens is you define an order.
Okay.
For example, in real line, there's an order defined at a point if these are 2 points and if x lies here on the left of y, then x is, so this is an order defined, right? You've been given an order. So you can tell which is the least number in a given set. So if you've been given a subset of real numbers, you can tell which is the least element there. You can tell the lower bound of that set. But
Yes.
this is not a subset of real numbers, right?
Okay.
And even if it is subset of some other set, even if it's subset of, it's a subset of D comma CD in this case, right? It's a subset of this set. Domain, Cartesian product with codomain, right?
Yes. Yes.
So you'll have to define an order here first. Then only you can tell which one is smaller.
Okay.
They'll give you don't worry about it. They'll give you the order if in case anywhere you're asked such questions, not just in this course. If you're asked anywhere such questions, you'll be given an order.
Okay. Okay.
Okay.
Ma'am,
Ma'am,
if
question number
can
9.
tangent intersect another point in the curve? Ma'am, can a tangent intersect another point in the same curve?
Yes. See, this is your tangent. If you draw a tangent at this point, so you will have this thing, right? So tangents are geometrically, when we talk about tangents, it's something different. And when we talk about it in terms of derivatives and all, it's something different. Here it's just for the direction and the change in the function. So there, when you discuss it in context of graphs, it's about the function and its rate of change and the direction of that rate of change, the direction of that change. That's what
Yes,
it
ma'am. If the tangent intersects another or more than one or two points, can we consider it a tangent, or it's something like another function like that?
it would intersect only one point. You just keep in mind that it intersects one point because that one point matters. If you'll extend it, its tangent is a line, so it keeps extending, obviously. It gives the direction. So if you just do this thing, it can, if you like extend it further, I don't want to confuse you. All you have to keep in mind is it touches the graph only at this point. That's it. Only at one point.
Okay.
Okay.
Ma'am, question number 9 of the same.
Question number 9. There's a function from A to B where A, B are finite subsets of R. Which of the following options are correct? The cardinality of this is the graph of F, right? Is the same as cardinality of A cross B. So if you have if F is a function, we just discussed this when we were discussing a set of 4 and the codomain also had 4 elements. So it's, let's just say, for making things easier, let's just say your A has 4 elements and your B has 3 elements. So when you plot a function or whatever, when you construct a function, you would have 4 elements here and 3 elements here. You just need to, and you need to find the cardinality of the graph. So it doesn't have to be A cross B would mean that you're taking every pair, every element from here and every element from here too. This is, do you know what A cross B means? What is the collection A cross B? Can anyone define this collection for me?
It is a Cartesian product of the set A क्रॉस B, जिसमें A सेट जो डोमेन होगा और उसमें सारे एलिमेंट्स जो होंगे वो फर्स्ट पोजीशन पे आएंगे, एंड जो सेकंड पोजीशन पे एलिमेंट्स आएंगे पेयर्स में वो बी को डोमेन के होंगे इसमें, और इसमें A क्रॉस B में जितने भी पॉसिबल पेयर्स बनते हैं वो सारे आएंगे.
Yes. So what happens there is that you need to consider every element of B here and every element. So if, let's just say there are 10 elements here and 10 elements here, so you'll have to consider every possibility. You'll have to consider A1, B1, A1, B1, B2 till A1, B10. So you'll have to consider every possibility that's there. That's what Cartesian product means. But that's not the case when you try to figure out the graph of a function. That's not the case. You don't have to pair this thing. This needs to be paired with only one. In fact, you can't pair it with any other. If you've paired it with this one, you can't pair it with any other. That's how functions are defined. So if this is A1, again A1, A2, A3, A4, I'm just taking the cardinality to be 4 and 3 to make things simpler. That's all. Then we can just consider the bigger sets here, and then we can just normalize it for that. So A1 can be mapped to only one element here. So you can just have, if A1, B1 is already there, you can't have A1, B2 because then it's not a function. So the cardinality, it's obviously, we don't know yet what how many points are there in the graph of this, but they're definitely not A cross B because A cross B contains every possible point, whereas this does not contain, the graph does not contain every possible point. A1, B1, if A1, B1 is there, A1, B2 cannot be there. But if you'll take A cross B, A1, B1 is there, A1, B2 is also there. Is this okay? Why the first option isn't correct?
Yes, ma'am.
Okay. The second one is the graph of X has the same cardinality as A. So if you look at the graph of F, the cardinality of this and the cardinality of this. And that's actually true because what's the cardinality? Let's just see here. The cardinality of A is 4, right? With 4 elements here. And the graph is also going to have 4 elements. Why? Because you'll have A1, let's just say A1 is mapped to B1. A2 is mapped to, it can be mapped to B1 as well, because that's also a function. You can map 2 elements to the same element. That's fine. So A2 will be mapped to something. When you're defining a graph, no, in terms of set, what you need is X, Y. You just need to know the definition of this. That's all. So what you would want here is, here you would want every element from the domain. So you would want A1 to, A2 to, A3 to, and A4 to. You want all of these elements to be here. A1, A2, A3, and A4. Because otherwise, you can't have a function where every element in the codomain is not mapped to some element in the, every element in the domain is not mapped to some element in the codomain. Every element in the domain needs to be mapped to some element in the codomain. That's why every element of the domain needs to be here at the first position. And then you can just decide whatever here. It doesn't matter. We don't even know what the graph, the function f exactly is. We don't know the elements here, but we do know that there are 4 elements here. And exactly 4. Because if you have A1 here, you cannot have any other element different from this one, different from this one. Let's just say if this is A1, B1, you cannot have A1, B2 here. Because then you'll have to map these to 2 points. You cannot map one element in the domain to 2 different elements in the codomain. That's not a function. then it's not a function anymore. So this is the correct option. The cardinality of the graph of f is the same as cardinality of b. It's not this. B has nothing to do with it. Just have a look here. We just said that we don't even know what's here. From the set B, we don't even know what elements are going to be here. It could be, you can map, let's just see an example that let's just see an example that just proves that the third option is not correct. We'll have a counter example for the third statement. It says the graph has the same cardinality as B. So let's just take the function to be this. This is a function, say this is set A, this is set B, and we're taking 3 elements here, and we're mapping everything from set A to this same point. This is a function, right? This is a function, it satisfies all properties of a function. And if you look at a graph of it, now the cardinality of B is 3. But if you just just write down all the elements that are there in the graph, it will be A1, B1, A2, B1, A3, B1, and A4, B1. So here we have 4 elements, but here we have only 3 elements. So in B, the cardinality of the graph, this is the graph, right? This is 4 here, whereas the cardinality of B is 3. So they don't have to be equal. So this is incorrect. And then you have the fourth option. This cardinality is less than equal to the cardinality of A cross B. Okay, so have you studied relations and functions at any point? Or have you heard of relations and functions?
Week 1.
Yes.
Week 1.
So you have done relations and functions, and you should know this. So if A cross B, this is the Cartesian product of A. And if you define a function on A, so relation is a subset. You must be aware of this thing. Relations are subset of this, right?
Yes, ma'am.
So if you have, is this clear, or are there people who don't know this? Anyone who's not familiar with this? And then functions, when we talk about functions, they have even more restrictions. Must have done when functions, relations, all relations are not functions. All functions are relations. Is it, are you guys getting it? Do you want me to explain everything? I need you guys to respond at least so that I know who.
मैम फॉर पीपल जिनको नहीं पता है उनके लिए बता दीजिए तो उनको पता चल जाएगा.
If you've done relations and functions, it should be there. So A cross B is the, when you take a set, let's just say A, you have A1, A2, A3. We're not taking a lot of elements. And then B, let's just take only 2 elements, B1 and B2. So if you're taking this, then in A cross B, you'll have every possibility here. A1 starting from A1, B1, and then A1, B2, till A4, B1, A4, B2. And here you have A1. Let me just mention all the points then. So this is the Cartesian product of A and B. And then if you define a relation, so relation is basically a subset of this. It can be equal to this. A cross B is also a relation. but it could be any, you can pick any elements and put here. This will be a relation then. Relation is basically you relate two elements, right? From one from set A, one from set B, and then you relate these two elements. That's what you do in relations, right? So a relation is basically you just pick any elements from here and then you write them down here. So it can, A cross B is also a relation. Is there a doubt till this point?
No.
Is this clear till this point?
Yes.
Or when you define functions next, functions are particular type of relations where what you want is, you would want that, first thing that you'd want is that if A1 is here, then there should be no other element that starts with A1 other than this one. So if there's another element A1 and there is something different here, not equals, let's just say there's X where X is not equals to B1. It shouldn't be in this set. Because that's how you define function. Every point should have only one image. It should not have two images. If you'll have A1, B1 and A1, let's say B2 here, then you'll have A1 and then you'll have two images of A1, B1 and B2. So that's one restriction here. And the other restriction is that if you have A1, and you should have all the elements from the domain here. So if A1, A2, A3, A4 are in the domain, then you should have A1 here. You should have A2 and something here, A3 and something here. That's how you define a function, right? This is a function. So the question asks, is gamma f, so this is a function that we define. This is actually the graph of that function that we've been discussing for so long now. This is the graph of the function. Is it a subset of the A cross B set? So it's a subset of the domain and the codomain. And if A is your domain, then it's a subset of A cross B. Is this okay? So if this means this set is contained in this set, which would mean that the cardinality of this set, the question is about the cardinality. So it will be less than the cardinality of this. Is there a doubt in this particular option? So this
It's
option should be correct.
less than or equal to.
Less than or it can be, yes, it's less than or equal to. It can be equal as well. In case of, let's just say you have a 1, 1 onto function, then every element here is mapped to some other element here. And one element is only mapped to one element. So it will exactly give you complete A cross B. So if you have a 1, 1 onto function, if you have a bijective function or a bijective function, the cardinality of your graph of F is the same as A cross B, where A is your domain, B is your codomain. Is it okay? Does anyone have a doubt in what we have done so far in the graph thing?
Ma'am, I have just joined. If time is there, then can you explain this one more time?
Which one? Which part do you want me to explain? It's a very long thing actually. Okay, so
Okay, ma'am, no problem. I will check from YouTube later on.
okay, if there's any doubt, if there's still doubt, you can check it on YouTube, and if there's still doubt, we can discuss it in the next class maybe. Any other doubt? Any other doubt till this part? It's a bit confusing, so it's okay. You guys can ask if there's anything. You want me to explain this point in more detail? Any other doubts from 7.3? Otherwise, we'll move on to 7.4 then.
7.4, ninth one.
Ma'am, in 7.3, have you discussed the question number 7, 8, and 9?
7.3, wait. I'll have to see which questions are you talking about.
From 7.3, question number 7, 8, and 9. If you have already discussed, then no problem.
7, 8, 9. Yes, these 3 questions have been discussed.
Okay, ma'am, no problem then.
Okay. Which question? 7.4?
Ma'am,
Yeah,
from
ninth one.
and ma'am, from 7.4, I want to discuss question number 7 and 11.
Okay, let's start with 7. There's a sequence AN. This. Which of the following options are true? The first is AN is convergent. Let's just see if AN is, if you look at this n tending to infinity, let's just say, you need to find this, right? So if you do this, you'll get infinity minus infinity form. We've discussed this form is a complicated one. You need to further simplify things in order to get rid of this form. So what we do here, and we've been used to dealing with these forms. So most of the forms that we've discussed so far are 0 by 0 forms, right? You don't have to remember all these forms, by the way. But I just want you to notice that this is there. That's why that's why this needs to be simplified further.
Yes,
So,
ma'am.
this is what you've been given. What you can do is you can just do this thing. It's like rationalization, but it's not called rationalization in this particular case. This. So
We are making it
yeah.
a square minus b square form.
Yes, that's what we want. So that we just
Okay.
get rid of the infinity minus infinity form. To get rid of this
Okay, ma'am.
form, we're multiplying and dividing by the same thing, this thing. And then we'll get 2n plus 1 minus 2n. We're doing this because all the forms and everything that we've done so far has been in fractions most of the time, where you have a thing here, a function here, and then in the denominator there's another function. We're trying to make it of that form. So we'll have 2n plus 1. This is the square of this thing and square of this thing. And this is 2n plus 1 plus root 2n. So this thing is going to give you 1, and this is n tending to infinity. So if this goes to infinity and this goes to infinity, both of them are going to infinity. One more thing that's there is, if you see, let's just say you have two things here, a n plus b n. We've seen this, that if the limit, we've discussed is that if these two limits are finite, then we can just separate the limit over these. But we can do that here too. Even though these two limits are not, if you look at this, square root of 2n plus 1 tends to infinity, and square root of 2n also tends to infinity. So if you don't see, if you have an infinity limit and an infinity limit, this will give you an infinity limit only. So if you have infinity plus infinity thing, that's going to lead to infinity only. But if you have infinity minus infinity thing, that was the case with the initial problem, then this is an indeterminate form. You don't have to remember the names. You just have to remember that this is a troubling troubling thing. You need to you need to simplify the things further to get rid of this form. This is fine. This is tending to infinity. This is also tending to infinity. So the whole thing will tend to infinity. You can look at like if there's infinity is like something very huge. So if something very huge is added to something very huge, you'll get something very huge only, right? But if you'll subtract, if you'll do this, this is something very huge and this is something very huge. But these two very big things are not equal. So you won't get a zero here. It's like a very
Yes,
big thing, and we don't know what we'll get. For example, if you have 2n and n, so both of these are, in this case, you'll get a zero only. I hope I'm not confusing you people. It's the
no,
thing
ma'am, we are
is a
okay.
very huge number. These two numbers are not equal. This is some very huge thing. This is some very huge thing. So we don't know if we'll subtract it from this, what will we get? This is definitely not zero. That's why this is a troubling form. And infinity plus infinity is fine. It's still infinity. This is not a troubling form. So you can just take the limits here. So this whole thing is tending to infinity. So we've discussed this. If an is tending to infinity, then your 1 by an should tend to 0. This thing should tend to 0.
Okay, ma'am, thank you.
Okay. Any other doubts from this exercise?
Can you take
Same,
ninth
ma'am.
one? Ninth one.
So we have an one sequence and bn another sequence. And it's been given to you after a particular number. So this means, let's just say this is m. So after, for m plus 1, m plus 2, m plus 3, and so on, so on. So after m, your am, this is what it means. Am plus 1 is less than bm plus 1. Am plus 2 is less than bm plus 2. And so on, so on. This is what it means. So after a particular stage, you have this true for all n greater than equals to m. And you have been given that your limit of bn. So in sequences, see if you have a sequence, this is one point that I want to discuss. If you have a sequence, this. So if this is say tending to some a, and if you start this sequence from say a very huge number, and then you take it from here afterwards, then this still tends to a, right? So even if you remove
Correct.
this part, any
Yeah,
parts
yeah.
from here, any finite part, it still tends to, and you can only remove finite part only. There's no way you can, because infinity is not even a number. You can't remove it from here. So you need to know how many terms to remove from the start. Even if you remove a lot of terms from the start, this still tends to a, right?
Yes,
So this
ma'am.
thing it's of no importance here, because in loop terms you can just assume that this is less than equals to this. That's why I just mentioned this thing, because you can consider the sequence an from m only and bn from m only. And your question is, so limit bn is 0 and find the limit of an. So this is what you've been given, and your bn tends to 0. So have you heard of sandwich? You must have done this one. It's in the course. Sandwich theorem or whatever, where you take an and then cn is in between an and bn. So if this tends to say a and this tends to a too, so this tends to a as well, right? If an and bn tend to a, this implies your cn tends to a. This is in the course, sandwich theorem. So if you look
Yeah,
at
it's
this
there.
thing, you'll have an and you'll have bn, right? And then you can have a 0 here. Is this fine? 0, 0 is also a sequence, right?
Okay.
Let's just have this here. And then you'll have, and let's just take limit. Now this limit goes to 0.
No,
This
how do
limit
we
goes to
know
0 as
that?
well.
How do we know that an is between 0 and bn? It's less than bn, I understand, but it could be less than 0 also, no?
This is a mod thing, right? Modulus value is greater than 0.
Okay. It's a mod.
So your
Okay,
mod
okay.
an, this will give you
Yeah,
a
that's
mod
where
an
I
tends
was.
to 0.
Yeah. That's where I didn't understand. Got it.
So this just gives you this, but you need this thing. You need the limit of an, not mod an. This is also 0. Why? Because let's just say you have a sequence a1 where a1, a2 all are positive. Okay. This is your sequence, let's say, and you have a minus, minus somewhere in between. All right. So and a1, a2, a3, all of them are positive. So if this sequence is, let's just say that the mod of this is convergent to 0. That means your a1, a2, a3, ai's are all greater than 0. Right? This thing is convergent to 0. Then can I say that this converges to 0 too?
You're saying we can say, but I don't understand why.
Okay. We can say obviously. It's actually this thing. We'll see how this happens. When this thing tends to 0, this happens if and only if. That means if this is tending to 0, your an is going to tend to 0. I don't have to write it. If this happens, then this is going to happen, and if this happens, this is going to happen. Goes both ways. So why does this happen? Let's just make a subsequence of this thing. You'll have minus a1, minus a3, subsequence of negative terms. This is a subsequence, right? Minus a4, and we'll take all the negative terms. And then we'll have a1, a2, a3, and so on. We'll have a2, and the next positive term, let's just say a5 is positive. We'll take a5 here, and all the positive terms. So we'll collect. So firstly, you need to see that these two are subsequences of the given sequence. Can you see why these two are subsequences of this?
Yeah, that I understand.
Okay. Now this whole thing we know is going to 0, right? So if an is going to 0, then subsequence is going to 0 too, right? It's like this thing. If you have this thing is going to 0, and then you pick random points somewhere. Let's just say I'll pick this one, this one, this one, and I'll keep going on. So if the whole thing was going to 0, these picked ones will also go to 0, right?
Correct.
So this thing will go to 0, and this thing will go to 0 as well. That means your whole sequence. Wait, what were we discussing? We were discussing it backwards of. We were discussing it as this. Mod an is going to 0, right? Let's just say mod an is going to 0. That means the positive. See, if mod n is going to 0, then this is positive only. This is going to 0. This thing is going to 0, right?
So didn't understand the last part. What did you say? Mod 1?
We need to prove this thing, right? If mod an is going to 0, then an is going to 0.
Correct.
This is it. If this thing is going to 0, either this is a positive thing or this is a negative thing, right?
Correct.
Let's just say that this is the original thing. And to keep things simpler, we'll take the alternative signs here. I just have this thing that the first term was negative, then second positive. Let's just say this is the actual thing, an. And then if you take the mod, you will just have a1, a2, a3, and a4, and so on, so on. And this thing is going to 0, right? So if this thing is going to 0, then do you agree that your a2, a4, A6 is also going to 0.
Yes, ma'am, because it's a subsequence.
Yes, we just discussed it. So this is also going to 0. And what about this one? A1, A3, A4, and so on, so on. This is also going to 0, right? A5. This is also going to 0. And even if you put a negative sign here, it still goes to 0, right? Let's just say you have 1 by n. This is going to 0. Minus 1 by n also goes to 0, na? It will just have different signs, but eventually they're going to the same thing. Graphically,
No,
if you look at this,
I don't understand the mod part. See, when I say mod A1, mod A2, mod A3, I can have either positive or negative on A1, A2, or A3. By changing the term sign, I can write multiple sequences, correct?
yes.
So I can write minus A1, A2, minus A3, minus A4, minus A5.
No,
I
no,
can
you
write
can't.
A1, A2, A3, A1, A2, A3, A4, A5 also will satisfy mod A.
If you have
So
this sequence, wait. If you have this sequence, let's just say A1, A2, all of these AIs are positive, all right? Then this is a sequence, let's say. Mod of this sequence is this, right?
mod of that you're saying is sequence. Okay, okay,
This is it, right?
correct.
This is going to 0. And you
Hmm.
need to show that this thing also goes to 0, right?
Hmm.
So when this thing goes to 0, I can just
Hmm.
say all the terms that are all the even terms. If we construct a sequence using all the even terms, that's also going to 0
Yeah, that will
using
go to
this one.
0. Yeah, from that, yeah,
All the
I
odd
can see.
terms also go to 0. Now, if there's
Odd
a
terms
negative,
is negative.
this is negative, right? We
Correct, correct.
Okay. Let's just have
Odd term, even term going to 0. Understood. What if
is
they
this
have
part fine?
negative? Now it's fine. Okay.
What we did here is if your sequence, let's just say you have a sequence an and this is going to 0 and minus an
Hmm.
is also going to 0, right? This is, have you done this? That if an is going to a, then can is going to ca.
No, I understand an going to 0 minus a1 goes to 0. But I can pick and choose here, no, on what is negative, what is not negative. Won't that have any constraints over the limit?
Let's just start from the very beginning. This is a
No, no,
sequence,
no.
right?
I
This is a fixed
understood.
sequence. Now you can't change it.
Yeah, now I
I
can't
have
change it.
taken
Correct.
this
Correct. I
sequence for
can't change it.
simplicity.
Okay, I got it.
I've taken alternative terms to be positive, negative for the simplicity of the sequence. Otherwise, it could have been anything.
It could have been anything. Let's keep it that it could have been anything. Okay.
And this is the modulus of the
Yeah, that I
sequence, which is going
understood.
to 0.
Odd
This
even going to 0 understood. Odd going to 0 understood. 1 by n
and
going
if
to 0 means minus 1 by n go to 0. That also understood. My
this is
only
not needed.
no, even
Yes.
that I
What's
understood and saying. My question is, see, if when I can pick and choose from the original, I can have any signs or pattern. An could be of any sign pattern, anything like positive, negative, negative, positive. Can have any pattern,
yes,
but in the in from we are deriving from the mod a1, correct? Mod a1 only we are deriving all this. In mod a1, uh, how do we make sure that an is exactly minus of mod a1? If you get it, it could be anywhere. No, any
if you
element could
let
be
me
there.
complete this, and then if you still have doubt, let me just. I
Okay,
think you're not
okay,
letting me
okay.
complete. That's why you're not understanding. So
Got it. Okay,
this
I'm
is
gonna mute myself.
okay. So this is you understood till this part, right? So now you have a. Let's
Yeah,
just
yeah.
come back to our. We need to show that this is going to 0. Let's just write it down again. You have a1 minus a1, a2 minus a3, a4, and you have this sequence, right? This thing, let's just say you have this here. And if you collect these points, this one, this one, this one, because we have taken alternating ones, so we're taking these ones. And these all are going to 0, and then the other ones are also going to 0. So there's nothing left, no? So everything is going to 0.
Ma'am, can we say that the limit of first and the last will be the same as the limit of the middle one?
Are you talking about the sandwich principle? This one?
Yeah, sandwich principle.
That's what it is. It says that the limit, if this thing tends to say A and this thing also tends to A, then this implies that your Bn also tends to A. That's your
Yes, ma'am. This
theorem.
is now what you thought is the applies to sandwich rule, right?
Yes. You applied sandwich rule in this one. But
So
from
my
that you
question was
only get
how mod
mod of
A1,
An.
mod of A1 and A1, how would both of them have a if and only rule between them is what one question is. Okay, I'll dig into this. I'm still like I'll try to understand. If I have any questions, I'll ask it clearly next time.
Okay. Let's just move to other questions if there are any from this one. Any other
Yes, ma'am.
questions?
Ma'am,
Yes.
7.4, question number 11.
So this is the sequence. Right, and we need to figure out if it's a decreasing sequence or not. We have to figure out decreasing and increasing sequence. Right?
Yes, ma'am. Yeah, I want to know the approach.
The approach is if you have 3n minus 5, let's just see if this is an increasing function. What is this? Is it increasing? Is it decreasing? What is it? Right? So this thing, if you look at, let's just say that n1 is less than equals to n2, you'll have 3n1 minus 5 less than 3n2 minus 5, right?
Yes, ma'am.
So this means that it is an increasing sequence. And if you look at 4n plus 2, this is also an increasing sequence. Now this thing is, let's just divide it with, let's just do one thing. We need to know what exactly is happening at the end. When we talk about sequences, we're more interested in the eventual behavior of the sequence. So let's just divide it by n. That would be a simpler approach. We can go by this approach too, but we're skipping it for now. This
Yes,
will
ma'am.
give
So
you
we can
5
divide by
n.
n. Yes.
Yes. And if n tends to infinity, because why are we taking n tends to infinity? Because we want to know the eventual behavior. What happens when
Yes.
n is tending to infinity? So this will give you 3 by 4, right?
Yes, ma'am.
So 3 by 4 means it's going to 3 by 4. That's
Yes.
actually. Let's just
So,
do
ma'am,
this
what
one
about
only.
increasing? Yeah.
Yeah, we were doing that. And you have not done the derivatives thing you said, right?
Yes, ma'am.
So,
Not yet.
okay. What I was talking about here is that we know that this is an increasing sequence and this is also both of them are increasing sequences, right? But we just need to see which one is, this is an intuitive approach and you'd see why this happens. Because if you have, this is also increasing, this is also increasing. So if you, let's just say you have an by bn and your numerator is increasing and this is, let's just say this stays constant, then this is increasing, right?
Yes, increasing upon constant, it will be increasing.
Okay, and if this happens, if your numerator is increasing and this is constant, then this is a decreasing sequence, right?
Yes, yes, ma'am.
Okay. Now what happens is both of them are increasing. So we can't figure out which one is deciding the
Yeah, the
increasingness
rate
or
of,
decreasingness of it.
yes.
Yes.
Ma'am,
So what
can
we do
we,
here is,
ma'am, instead of that, can we just play place and get the value like a. We are just considering x is equal to 1, x is equal to 2, x is equal to 3, and comparing all
But
the three results,
what
it's increasing
happens
or
is,
decreasing.
yeah, you can do that, but what happens is, firstly, it's going to take time. Other problem with this approach is that sometimes functions are increasing initially and they start decreasing. That's the problem. So if you substitute value, you can't keep substituting. You don't know after which point would it start decreasing. That approach
ma'am.
won't, in general, it won't work. So this
Oh,
is increasing
but
and this is increasing. Yes,
ma'am, but one thing, ma'am. In this case, they are just asking it's a decreasing or increasing function. If it is like decrease and increasing means neither increasing nor decreasing, right?
yes.
Then at the 2 or 3 points itself, if we get increase means, we can figure out that it's increasing function.
Can you repeat your question?
Ma'am, in this question, an function is given that, and they are just asking that it is increasing or
I
decreasing.
can't hear you. It's,
Ma'am, now can you hear me?
Yep. Yes.
Ma'am, this question was given that this function is increasing or decreasing. It's a two option question.
Okay.
If we just replacing a value like x is equal to 1, x is equal to 2, x is equal to 3, for three values itself, we get to know that it's increasing or decreasing. With the three values itself, we can conclude that it is increasing or decreasing function. If it is increasing at some value point and it decreasing at some point means it's neither increasing nor decreasing, right? It's another
Yes.
option from the answer. So we can kindly
Your
judge that
voice is
it's
breaking again.
now
After
now it's
it's still little. Yep. It's fine now.
Can this method work
So
applied?
your voice is, it's not clear. Can you just drop your doubt in the chat box? That would be easier.
Okay, ma'am. Sure, no problem.
Okay. And please do it quickly because the time's almost over. So we were talking about this thing, 3. So we just need to see which one, what's happening here is numerator is making the sequence increasing, the denominator is making the sequence decreasing. So we just want to know which one has more effect on this. So when you look at this, this really doesn't, when you have a constant thing, no constant things don't actually affect the overall sequences. They're just there, but they don't affect anything. They don't affect the long-term behavior of sequences. So you just have to focus here. So what's happening here is you just have to focus on this thing, right? So now if you have n, you'll have, let's just say I keep 1 here. So I'll have a 3, and then if I'll just take a 2 here, I'll have a 6, and then I'm just doing it for you to observe that this thing is increasing more rapidly than this one.
Yes, ma'am, the denominator will increase more rapidly than numerator.
Yes, right. So by that logic, it should be decreasing then, right?
Yes, it should be decreasing. Yeah. Because the gap, eventually the gap will started becoming smaller and smaller.
Yeah. But see, it's not a major difference because we don't have these things here. It's not like it's not something like this. So we won't see it decreasing very rapidly, but it would still be decreasing. Is that
So, ma'am,
okay?
yeah, it's okay, ma'am. Can we conclude and use this approach for like solving for like, so this is like working approach and we can use it for solving an exam.
Wait a second. I don't think it's a decreasing sequence actually. It's because if we use this is the approach that it's the thing here is that you have an n on both numerator and denominator. So it's not a major thing here, not a major change as in n and n square. So what you do here is we'll just try to look for another approach. But for now, what we can do is it's the derivative approach that works because
Ma'am,
Ma'am, can
maybe
you
you
now hear
tell,
me, ma'am? Excuse me, ma'am. Can you
ma'am,
now hear me?
ma'am, maybe you tell the derivative approach. I'll try to understand because eventually we have to learn it.
it's just you just need to find the derivative of this thing and then you'll have to see if the derivative, let's just say this is f, so if the derivative is greater than 0, it's an increasing function. If it's less than 0, it's a decreasing function. That's all.
Oh,
Ma'am, can you now hear my voice?
Yes.
Yes, ma'am. Ma'am, I don't know what happened to my chat box. It's just making some trouble. Ma'am, with 3 or 4 options, we can find out that it's an increasing or decreasing function, right?
What?
Ma'am, with the given of 3 or 4 values, we can find out that it's an increasing or decreasing value, right? Function, right?
You can just get an idea. It's just a rough idea. You can't actually predict if the sequences eventually, eventually what's going to happen, you can't predict. The other ways for that.
Yes, ma'am. But they just given only 2 options. It should be an increasing or decreasing.
Are you talking about this particular question?
Yes, ma'am.
If it's an increasing sequence, you tick yes. If it's a decreasing one, you tick yes. It's if it's neither of them, you can just cross it. It's quite possible that it's neither increasing nor decreasing.
Oh, okay, ma'am. Yes.
Okay.
Yes, ma'am. Thank you.
And about this one, about the other options, it's -1/6 and -5. So 6 and -5 is an increasing sequence. That's the way we did the previous one. So 1/6 and -5 is going to be a decreasing sequence. And if you put a negative sign, it will become increasing again. This is an increasing sequence. This one's this one's an increasing sequence. If you'll have this thing, this is you can use it's the thing that I can think of right now is of the derivative approach only. Give me a second to figure out another approach if there is.
or ma'am, maybe we can discuss in next class because now time is very short. But if there is a way where, I mean, if you can tell us, those who have not learned derivative till now, if there is any approach you can help us with, it will be great help, ma'am.
We can do conjugate here, no? Like we can apply conjugate here, like how we did last time. Simplify it for 1 on numerator.
Yeah, that we can do with this one, but we not with this one, right?
Yeah, that one we cannot, but for this I think we can do.
This one it will work. You'll have this thing and this will give you this thing. So this whole thing is an increasing sequence. So if you take the reciprocal of this, that will be a decreasing sequence. And what's the last option? I think the time's almost over. So we'll take this up, the last part of this and the first one in the next class.
Yes, ma'am.
Okay. Thank you all.
Thank you so much, ma'am.
Thank you, ma'am.